Hallo Freunde, ich hoffe, dass alles ist in Ordnung für euch. Äh, ist 10 Uhr in Redmond und dieser ist .NET API Review. Don't know why I did German since I just spent a week in France, but apparently I don't like speaking French, so German it is. Uh, Bienvenue en français. I don't know. Plurals in French are beyond me. Right. So, we have a focus review today on some JSON topics. So even though we have a big long list of stuff, some of them are red, some of them are JSON. Today is JSON. If your name is Jason, no, we're not talking about you. Great. So, developers can customize the JSON serialization contracts of their type 63686.
Is it
Anyone?
my turn to talk?
Yep.
Okay. So this issue is about customizing contracts in JSON. This specifically means like when the serialization happens, users would like to have more control over what happens when that serialization happens. In example, like if you want to say add property to every single type you serialize, you can do it. So if you scroll down for me to the examples, there are a couple, like the second example on the list. Yep. So there's a specific example of how this could possibly be used in practice. So in example, in here we have a data contract attribute, which is an existing JSON type. And now you defined like a JSON type info resolver. The JSON type info is what we call contracts in here. And what you can do in here, basically, like you get an existing JSON type info on the first line, which calls the base get JSON type info, and then you check what kind of type info you're on, if you're on the object, and the specific type has the custom attribute. You want to do special stuff. So now you start with cleaning all of the properties, and then you basically do your own thing, which is like adding your own properties with your own getters and setters, of however you define them, and you basically add them back to the contract, and then basically serialization happens in the way you want. So this is actually a second meeting. I've already went through like all more details on like how this exactly works. So previously we finished on the bunch of questions and a couple of basically feedback I had to address. So let's maybe quickly recap the APIs first, and then I will tell you what kind of changes I've made to the proposal, and that's it, I guess. So yes, the APIs are basically on the JSON serializer options. You have a type info resolver property, which if you set, the custom logic will happen. By default, you will get the default contract resolver if you call the getter, and because that uses reflection by its linker unsafe. Now also the existing JSON serializer context class, which is partially defined by user and partially generated, also happens to have properties of the JSON type info resolver, which means it will now implement JSON type info resolver interface. The next thing is obviously the interface. The interface only returns the nullable JSON type info. Null means I don't know how to handle it, and it might mean fallback to another resolver, or it might mean I basically throw an exception if that type happens, depending on like how you combine the resolvers. That might mean different thing. Now the default JSON type info resolver is obviously the default logic, the default reflection logic for the type resolution. Then the JSON type info kind is basically, if it's an object, you can set properties. If it's an enumerable on dictionary, this is kind of like a v2 values. It means like the JSON type info will also have ability to change some other properties relevant to enumerable or dictionary. But the object enumerable and dictionary will be set only if we know that JSON converter understands the specifics like of what it's returning. So basically, if it's a custom converter, we kind of don't know like what the user will be serializing, so we cannot tell object enumerable or dictionary. We have to say none. The next thing is the JSON type info, and the JSON type info is already an existing class. We only remove the editor browsable attribute. So it has a couple of properties like type. It's get only because you provide the JSON type info for the specific type, which means you cannot really change it once you construct it. Now it's also always one-on-one mapping with the options. It has the converter because we already have mechanism for determining converters, and we don't want to provide another mechanism to do that. It's also fixed based on what was determined during the regular converter picking logic. The kind is also non-settable. It's because it's kind of tied with the converter. So like if we know that the converter is of specific kind, like in example, if it's a default object converter, like we know it can support properties. Now, stuff you have to provide or will be provided for you depending if you use the default converter or not, is the create object function. So in order to deserialize, we have to create an object first in order to set properties. If that's not provided, deserialization cannot happen because we don't know how to construct the object. So now the next thing on the list is ilist of JSON property info. That's basically properties. The JSON property info will be described later. The choice of ilist is because this is an ordered list. It will be sorted like by default. If you use the default resolver, this will be sorted by the order attribute which was provided, which means this is an ordered list. And if you change the order, it will reflect on what order the serialization will happen. Next thing is the number handling.
So, Christoph, is it always the same list type, or does the type of the list vary for some kinds of type infos?
I would say it's not guaranteed. It will probably not change implementation-wise, but I'm gonna say we do not guarantee.
Well,
like, you can modify the list, but you are not guaranteed what type of the list is. It's currently the internal type.
I mean the general. Okay, so it's a non-public type.
Unpublic.
Okay, then that's a good reason to use the interface. It's people. They'll cast it, and if it's castable, then you can't ever change it because people. But okay, moving on.
Yep. The number handling, it's nullable because the null means, okay, I want to use the default options logic. If you set it, that means you overrode it. If you're using default resolver, this will be assigned to whatever the attribute you used on the specific type. Next to are the create JSON type info methods. It's basically for constructing empty JSON type info, and if you use the generic version of that, it will be linker safe. The other one is less linker safe, I guess. Also, the first one will be allows you basically to construct the type, use the typed create object, which if you use the non-type JSON type, if you get the non-type JSON type info, you will always have to basically do the casting on the create object method. So like we will get to that part later, and then the next two are
create object public. I just saw the new keyword there.
So can you repeat the question?
So you're talking about in JSON type info T, create object. There's a new keyword, and I was looking at the existing type. It's internal, right? The existing property.
I think it's internal currently, and it will be public, like with this proposal, basically. And the new is because the previous one is untyped.
Oh, I see. Thanks.
Yep, and basically, if you assign it to the type version and then you try to retrieve it from the retrieve it from the other one as the if you assign the typed one and you try to receive the untyped one, you will get something in return as well, and that will be corresponding func of object to that previous delegate. So I guess the implementation details are reserved here, but like this will most likely be a cached version of like a newly constructed delegates, which basically cuts the value. I mean, in this case, actually it doesn't cast, but the other way it would cast. So next two are the member methods. I mean, member methods, like the instance methods, create JSON property info. This is membered because we want to reserve rights in the future, basically to be able to add new. Basically, if you want to provide the generic version of the JSON property info, and in here it seems like I forgot to remove the create JSON property info of the property. So that was in the original design. Actually, we won't have it now. And the reason I removed it, I will explain later. That was basically one of the questions which happened on the previous discussion. So there will be only untyped JSON property info for now, and that's the proposal. Yeah, let's go to next type basically. So the typed JSON property info. So we basically cannot. They are both abstract. And basically the create JSON type info will give you the correct instance. It will be internal, and like you can only modify it, but you cannot construct it directly. You have to use the static constructor, I guess. Is that the term? Yeah. And the next class is the JSON property info, which describes properties. So it also has assigned options. It has a fixed property type. It has a name. The name is settable because in some cases you might want to modify it if you have an existing. If you have an existing property, you might want to modify it. But every JSON property info has to have a name. It has to be non-null. Otherwise, you cannot basically neither serialize or deserialize. Then the custom converter is nullable as well. Null means I want to use the default converter for the specific type. If you use non-null value, that means I want to use a different converter for the specific property. And like if you notice in the JSON type info, this was only get. It's because for the type we already can assign it for the specific type, and using the specific APIs and the options. Are you asking questions in chat, or?
I'm just taking notes.
Okay. Okay. Anyway, and now we have also get and set methods, and they are also nullable. Like if one of them is null, basically that means that either serialization or deserialization cannot happen. So basically the untyped getter and setter, they're pretty simple in terms. Basically, the first argument it's kind of the same as in the reflection APIs. It's basically the declaring type, and the second argument is the value you want to use from the setter, and then the getter is basically the value you return from the specific property. And should serialize func is means like if it's null, it means we always want to serialize specific value unless there is some other logic elsewhere. Like an example, you want to skip like all the default values. There is a property on the options for that, and also like if for the specific value you want the serialization to not happen. In example, you don't want to serialize, I don't know, -1 for ints. You can provide your own should serialize method and say if it's -1, I don't want to serialize. And the number handling is similar to the JSON type info. So basically, if it's not assigned, we want to use the default logic. If it's assigned, we want to go with the specific number handling. So, for example, you can parse strings as integers and stuff like that. So basically, I think that's it. So there were a couple of questions on a couple of notes on the last review. So basically, the first one was if we can rename the can serialize to should serialize. So yes, that happened. The next one was we should. Actually, I'm going to skip the next question and come back to it later. So another question was about the JSON property info being generic. So there was a basically proposal. Maybe it should be JSON property info of T. Maybe it should be JSON property info of two types. One is the declaring type, and the second one is the property type. And the answer for that is I've done some investigation on the different types of getters and setters. So basically, the problem here is like if the say we meant with the double with the two argument generic, so the declaring type and the property type. So in case of structs, for the declaring type being struct, that causes problems basically that we cannot directly use things like a setter, which would be action of, in example, the declaring type and property type. The declaring type would have to be ref, because like otherwise we wouldn't be able to change it on the change it, because you would always get a copy of the declaring type and not the actual original struct. So in case of untyped one, the problem doesn't exist because it's an object, and if you want to change the struct, you have to use the unsafe.unbox APIs. And that is okay. Since the JSON property info type already exists, we would have to probably provide the untyped version anyway. So that was basically one of the things which led me to leave the JSON property info and have getters and setter on that. So the reason we removed it though was because I've done some basically benchmarks kind of that were they were only tied to specific different types of setters. So actually, if you scroll down, scroll a bit down, there is I've added the section JSON property info something. This guy. Yeah, so basically run, if you open the benchmarks results, the first link on that. I hope this works. Yeah. So basically, I've tried for different approaches of setters and checked like the results. So I've tried different types of declaring types and different types of fields and properties, and seen what the results were. So my first proposed approach was to use the action of object and property type, which would be equivalent to the property info of the of property type, basically JSON property info of the two property type. So the first approach is something we would have to have anyway, so that's kind of our baseline here. The third approach is to use the double generic for the declaring type being a ref. It's not an actual action, it's actually a delegate, that's why I call it actionish, but that's basically equivalent to action, which has a ref keyword, but since you cannot do it with action, I kind of simplified it in the column. And the third option is to return the declaring type always. And I've run this for different types of benchmarks. So it seems like the third option for the declaring type and the property type using ref is pretty much always fastest. Sometimes the returning the declaring type is faster, but basically when you come into declaring type being struct, that basically is a super huge perf hit. Like if you scroll down a little bit, you will actually see the like basically we were talking like 3 to 4 times slower. So basically, so that was basically no-go, where the third option is pretty much always faster than the second one. So the reason, so that is basically the reason I removed the JSON property info of T, and the T being the property type. And because currently the implementation is basically not ready to support the third option, I decided to remove it completely, because that would be much more work, and we can add it in the future without any problems, which I've already prototyped before. And yeah, basically we can add and we will likely add something equivalent to the JSON property info of declaring type and property type in the future. That's at least the plan. Because it's basically the fastest option. So if we're gonna go with any of those, it makes more sense to add the fastest one. it's not the most convenient to use at the same time, because like if you want to, in example, assign the like if you use the reflection APIs and get a getter from those APIs, you cannot directly assign it to that delegate because it has ref now. So you have to basically create your own delegate. But I mean, we already have APIs for getting reflection, doing the reflection approach. You can as well use the default resolver for that, and most likely you won't have to do that. But if you have to do that, let's be fastest. Basically, that's the approach. So that is the reason I removed the JSON property info.
Yeah, I think that makes sense, honestly, because if you look at what Steve Harder's doing with the new faster reflection stuff, like he does have the plan to expose these members off of property info, field info as delegates, but your stuff will come in before that will. So I think it makes sense to stick with the plan that you're doing now.
Yeah. Yeah, that was basically the same conclusion I got with when I spoke with Eirik like offline. So okay, so let's. I will stop here because the last question is last comment note on the previous API review might take a bit more time. So let's stop here, and I'm gonna give you some time for questions now for the current stuff I talked about.
So one of the things, and this is kind of a side conversation we've been having in chat too, one of the things that other serializers do is they support a concept similar to iObject reference, which is you have a converter, you have a concept of abstract properties, for instance. You have a way to create the object that you're deserializing into, but is there a way to say, okay, I've deserialized into some object foo, but the thing that I actually want to return to the caller is a different object bar. The idea is that when you're going from foo to bar, like you look at foo as a temporary object that was created only for the purpose of deserializing properties, and then you're saying, okay, the actual object that I really want to return to the caller, I don't know what object that will be until I inspect the properties that I deserialized, and then make some decision based on that. We actually follow this pattern quite a bit throughout other deserializers in the framework.
But you're saying specifically about the properties or type infos as well?
For JSON type info, you had an idea of an activator delegate basically, but you didn't have an idea of a finished work delegate. So by finished work, I mean like I have finished deserializing all of the properties into this object, and now I want to return the object to the user, but the object that I want to return to the user might not be the actual object that I just created. It might be a different object, because the object that I created for the purpose of reading properties might be a temporary object or a builder object, something that the end user is not really intended to see.
Are you talking about like modifying stuff? An example, like when you do the dictionary and you want to populate the properties, or completely something else? So you can technically use, like different converter and then act on that. So like for an example, for properties, you could technically for the property type, you use whatever you want the deserialization to happen, but on the actual setter and getter, you can do whatever you want. You pretty much can translate
a concrete
else, but for JSON type
example,
no.
A concrete example that we have throughout the framework is when you're deserializing an encoding instance, for example, what we'll actually do across every deserializer in the framework is we will create a temporary object, which is basically like an encoding builder, for lack of a better term. And then we read the encoding name property into that, and that name might have a value of Latin 1, UTF-8, UTF-16, whatever. And then when we go to actually return the object to the user, we don't return them the encoding builder, because that's just something that we were using as a temporary thing. What we do in the end is we call encoding builder.getRealObject, and what that does is it calls encoding.getEncoding of whatever that property happened to be, which returns a singleton back to the caller. So the type that we return to them might actually be a completely different type than the type that we generated via our create object method. And like I said, that mechanism is supported by basically every serializer in the ecosystem, like data contract serializer, XML serializer, binary formatter, Newtonsoft. I'm pretty sure Protobuf supports it to an extent. They might all support it in different ways, but the way that we generally have to do this in the framework is through the iObject reference interface. And I wondered if you had a plan to support that or a concept similar to it.
So I honestly haven't thought of that. I mean, that's basically it. But I can imagine adding the support for that would be, I mean, it could be maybe adding another delegate like finish or something like that, which would basically call it in the end. I am not much familiar with the iObject reference interface to basically answer the question like how would that interact. I mean, also another like way you could do that could be probably like you add another static create JSON type info, will be maybe like create building JSON type info or something like that, which could do a specialized thing for this specific use case. Like
there are ways to do it. You had pointed out earlier that you could use a custom converter for it, but a custom converter for it seems like you would have to write a lot of boilerplate code for something that our infrastructure could maybe just give you in a single line of code.
Makes sense. Yeah, but I think the current API will not restrict us from doing that in the future. So basically,
okay.
I don't see anything preventing us from adding something like create building JSON type info, like whatever we call it, and basically that guy's supporting whatever like scenario you mentioned. So yeah, since the JSON type info is abstract anyway, we could just create another class which would extend on that and add extra functionalities if we really wanted to do that.
Levi, are you asking whether we can support this by providing effectively basically similar to the data contract example that Christoph has? Is the question whether these APIs here are powerful enough to effectively write this as a data contract adapter, or are you saying we should natively support iObject reference?
I'm suggesting if you don't natively support it, then you might want to consider adding the ability through these APIs to do similar functionality. And that would involve creating another delegate property, which is like finish deserialization or something, which is a func of object to object.
I mean, that certainly makes
exactly
sense.
What you have there, like the finish func.
Yeah, because the impression that I got in my head while Levi was talking was something like, immutable array. Granted, that's a collection type, which means it's going to be a different pattern here. But where in order to build it, like during deserialize, you would need to build an immutable array builder. But then the thing that you're going to return at the very end is a mutable array. So create object call can't even create the object of the right type because you need this intermediate placeholder. So it does seem like adding the object to object delegate here would be scenario completing.
Yeah, the immutable array example that you just gave is a very good example of where this would come in handy. They're not implemented via iObject reference, but it's the exact same concept. You deserialize into a builder, and then you call build at the end.
Yeah. So if we're calling the create object, would we pair it with finish object? Finish deserialize? Finish?
I guess.
Or complete object or something like that, yeah. But complete needs to be a verb, not an adjective.
Mm-hmm.
Is the discussion to add this at this time, or like we're still sort of like designing for the future?
It's really up to you, but I think we are neglecting a scenario if we don't have something like this.
Yeah, to me, I mean, there's a thin line between over engineering the current solution and future proofing it, right? I think given where you're going with this whole thing, which is basically the ability to write fairly non-trivial code without having to go through a converter, I think it would make sense to say, well, can we support the scenario that Levi brought up, because it seems like a fairly simple extension over what you were intending on supporting with this.
Does anyone know if Newtonsoft has precedent for this, or?
So, yeah, go ahead, Liam.
So I was just asking if anyone knows if Newtonsoft has precedent for this, and then that would be like a pretty good signal to see if we need it.
I believe they do, but give me a few minutes to look that up. But I'm pretty sure they support something similar. Anyway, yeah, don't wait for me to respond because it'll take me a little while.
Yeah, that makes sense. We can move on. Christoph.
Yep. So the last question on the previous, so that was a note actually, on the previous API discussion was to just the combinators pattern basically. So the options currently have the JSON type info resolver, like that's what I added, and I was talking about like how we could combine different types of resolvers. So, an example, there's actually one post, like if you Control F on this page and search for like nhibernate, I believe.
Search for what?
Nhibernate. How do you pronounce it?
Yeah, nhibernate. It's just N, yeah, like that.
Or just hibernate, yeah. It's somewhere in the bottom. Like one of the, or just search for James Newton King, I believe, or myself.
I suspect you have to expand one of those comments first, probably, because GitHub helpfully collapsed them. I think you want to search for show more first, and then click on those links a few times.
Well, assuming that the handy JavaScript that Steve gave
the
me
idea
doesn't work on these.
Start speaking like when we talk about it, but yeah, the idea is basically say like nhibernate or like F#, like as in here, basically they provided their own resolvers for several types they have, but they kind of don't care about anything else. How do we like extend the default resolver with those? So basically the idea was like we started talking about like how the APIs would look like. So if you scroll to the very bottom minus whatever Eirik T wrote, yeah, this is the exact post. So he basically proposed the APIs how the combined patterns could look like in example. So basically that would be extension methods into the iJSON type info resolver, and you could call like, I think he gave the exact usage like slightly, if you scroll slightly down. Yeah, scroll a bit down, yeah. So this is how that could potentially look like. So basically you can get the default behavior with fallback, even mentioned a scenario how you could combine the two different source gen contexts basically together as well. Yeah. So this is basically the idea. So this was kind of like a proof of concept of if the iJSON type info interface would work if we try to combine it with other things. Like we think this is kind of enough as a proof concept. Like we are not convinced we should ship it or not. Like we kind of are opinionless on this. Like it's really simple to add yourself, and at the same time, maybe it's useful to ship it now. We're kind of yeah. We're torn on how useful or how common that would be, because we don't have the actual numbers yet, because the feature doesn't exist. But the idea is basically you can add like basically two extension methods which could combine into another context, which could do stuff user wanted for you. I hope that answered the concerns about like if this design would work with.
Well, I mean, I'm just, if this is that, nobody needs to do it, or, very few people, then copying and pasting the sample is reasonable. But if it's a thing that people are going to need to do, then is this being considered as part of the proposal right now as well?
Yeah, like I cannot tell about the, like I don't really have data like to tell now. Like I guess probably makes more sense if like in my opinion kind of like better to have the interface and basically wait for feedback. Basically, if we see this people commonly doing that, I would then consider adding APIs. But unless we have like really strong data suggesting, okay, this is something we should do now, I am not sure. Maybe like I'm kind of okay with having those APIs as well. Like I don't mind, but like at the same time we are in the idea of framework having as little APIs as possible, while at the same allowing people to use what they want. Maybe that's my understanding at least.
I mean, yes, but to me, the reason why I pushed last time that we should think about this is that, to me, basically so your entire feature is effectively an extension mechanism how people can customize serialization, right? So my concern is that if we don't think effectively through how people compose this with types from different systems, their own types, third-party library types, and that sort of thing, then my concern is that the extension point that we give people will become a point of failure where they basically, have to handle types that they don't own and then do it incorrectly, or when you're a library and you want to give people who consume it the ability to use your extensions and have a way to easily register them, then I think that might become a problem for the feature where we don't like, the shape of the extension point we gave people, and that might be very difficult to change later.
Yes, I am honestly slightly, maybe not like super. I'm not going to say like I'm super opposed, but like at the same time, I'm slightly concerned about exposing those APIs now, because I can see someone creating an extension and then someone else also creating an extension, and they happen to define the same type somewhere, and they happen to basically provide their own contract for the same type, and then at this point you have to pick which one is your preferred one. And the moment you start adding the extensions and they start colliding, that's when the weird stuff can happen. Like, so I would probably, like, in my mind it's something like user have to consciously do. So like I would prefer to, in example, like define a class and basically pick, okay, if this is the type I prefer, then okay, I prefer the, I don't know, like what you call it, like left version, and otherwise I pick the right one. So yes, those are kind of scenario I'm slightly concerned. I don't know, like I basically don't have data like how, if that will be frequent or maybe it will never happen. Like it will probably happen, but it will like maybe it's like really unlikely to happen. Like I basically don't have data on this.
Yeah, I guess, I mean, this is, I think, my general question on this feature is like, how should I think of this feature? Like, is the idea that people who use the feature have to have total knowledge of all the types that they're serializing? Or is the idea that, if you're, let's say, serializing types and you use several libraries that participate in serialization, the idea is I can compose them? I mean, in practice, I think that's what people do, for better or worse. And it seems like your concern is that it may not compose, which I share that concern. But then the question is, how do we solve that?
I know it will compose. It's just I don't know if there is a generic pattern of like how people should do it.
Yeah, I think that's, I guess my concern is that if we say it will compose, but then we don't know how it composes or what patterns people use to compose, then how do we know it will compose?
No, it's because user picks like how they compose, and picking for user, like I don't basically, I am opinionless if this is a good idea or not.
Yeah, I guess that's my question, right? So like, I think so I guess this comes back to like, if I let's say, oh great, oh, fire alarm is tested again. I mute myself until it's over.
I guess, yeah, like I guess we could solve it and provide like some like basically the APIs Eric proposed. I mean, they seem relatively small and complete enough to solve probably most of the scenarios I've heard about, and I don't mind like I don't mind making them public. And basically, if user wants to make something more advanced, then they have to define their own class. I'm okay with that completely.
I don't know, Christoph. Did you see any examples from Newtonsoft about composing contracts from multiple sources?
And yeah, basically the unhibernate and F# was the example for that.
Unhibernate on Newtonsoft specifically?
Yeah, there was an example, basically the design conversation we've had with James Newton King about this.
Okay, thanks.
So yeah, basically, that was one of his initial questions about the say the unhibernate and F#. Like you want to use those two resolvers in the like when the ASP.NET app like is being configured, so they have like the specific builder part, and where you are being passed options, and you might want to add different kind of resolvers on the way. So you don't create the resolver, you kind of want to extend the existing one, and like how would user like achieve that? So basically that was the question. And yeah, like with the proposed APIs, I guess you could achieve that very easily.
So how are things like collisions handled?
Yeah, like if you have collisions, then basically you have to do it yourself. Like you cannot really prevent people from, like, most likely, like the scenarios I've heard are basically someone writes their library and they provide the resolvers for their types. But yeah, like if you have two libraries and they collide on something, what they do, I mean, you cannot protect from that really. So user will have to consciously choose which one wins. Order.
So on the default type, oh sorry.
No bad. So I was just saying, I see the examples now. Thank you.
So could like the default, like just spitballing, but if the default type info resolver had like a dictionary of type to custom resolvers or iType info resolvers or something like that, like could you do something where basically whoever taught the type first without calling base get type info would basically take over control until they called base again?
Can you repeat that?
So like basically the idea is like, what if there's a registry? Like what is the concern of having some sort of option to register a resolver for a type in like a dictionary where people could just like add things? Like, I'm only concerned about this type. I might want to in my library provide a custom serializer for it, and I would want you to mix it with other custom resolvers.
So generally the pattern is that the JSON type infos are being created on demand, but the resolver is kind of established. So so basically, like once you pick it and you start the serialization, you cannot really change the resolver. I mean, you're not supposed to, because at that point you might hit different kinds of problems. Like if you say you created a dictionary and you started adding values, and type at that point, that basically, like if you started deserializing on multiple threads and the dictionary might get destroyed, so you would have to use the concurrent dictionary that would become slow, and etc. So we internally have like our own dictionary instead, and you only can decide upon the construction. So basically, the resolver decides which one wins. So yeah, like if you want to basically pick which resolver wins, you have to have your own resolver, and that doesn't mean you have to construct the resolver, but you might use some kind of combining resolver or some kind of solution, like an example what Eric proposed in the post below. So basically, you say n Hibernate wins over the default resolver, and that's because the default resolver always returns the answer. Like it pretty much like for any given type, it will return something or it will throw. So like if you set the logic that default resolver will fall back to something, that will basically never execute. So you always fall back to the default resolver instead. So yeah, like and for like stuff like Hibernate and F-sharp resolver, they care about their own stuff, but they don't necessarily care about anything else. And you fall back to whatever you wanted. It might be the source gen stuff, it might be reflection logic, depending on what scenarios are you interested in. But they don't necessarily care about anything. I hope that answers the questions.
Yeah, I understand it's tricky. Like, I think to your point, you're not always going to be like splitting resolvers on type. Like, you might have resolvers that are dealing with like special attributes or something that could be on any type that they don't know about. And how would you combine that?
Yeah, like maintaining the list of all possible types. I mean, it's possible, but like, you know, you'd have to know all of the types up front, which means you like it's going to be hard, I guess.
For sure.
Yeah, but Imo, do you have any like? I hope it's quiet now.
It is. My ears are still ringing, but it's all good. Now, I went outside to see whether it's real this time or whether it's another false alarm, because I did testing last week, but turns out there's some construction here that tricked it apparently. Anyway, so my concern is basically when we say we expect it will compose, but then we are basically saying we're not entirely sure how users will compose it. And I think that's kind of the problem, I think, with serialization all up, is that we very often assume that the people that do write apps have total knowledge of all the types that are being involved in serialization, which is generally not the case, right? So the scenario that I have in mind is that, you know, use a library like the Azure SDK or something, and then you want to compose your own serialized types with the ones that come from the Azure SDK, and you want somehow that, you know, both of these, you know, custom serialization that you add to this interface play nicely with each other, right? And I think that kind of is predicated on the fact that we understand how, you know, users would like to compose them or have them composed, and then effectively, you know, design APIs for that. And if we believe, okay, this is a fringe API or this is an API people can trivially write themselves, then it's fine to cut it. But I think it would be a mistake to not design it, because we are saying we don't know how this will look like. But then at the same time, we're saying, oh, but we are confident that the API should that we have will allow users to compose it, right? So that seems like a kind of an unknown kind of thing that I'm not super keen on.
So I'm gonna say this, like in my opinion, like what like basically the two APIs Eric designed. So basically the with fallback and the I forgot what you call it, combine or something. So those two scenarios, like I think will solve all of the cases I've heard about. And in case you want something more special, then you can write your own class. So if your concern is okay. We should provide patterns people should use. I think those two are the way to go. Yes, do I think there is more scenarios? Maybe, but can I prevent users from doing the wrong thing? I cannot. So I guess those two are as close as we can get to the right design, I think.
Yeah, let me try to be more specific. What my concern is, like, I don't think it's necessarily to like have an API that's impossible to misuse, right? I've very often said that I'm not a fan of that either, but I think to me the question is, when you think about how serialization works, right, you basically have a system that walks types, right? And types are fundamentally recursive, right? Things can contain other types and stuff like that, right? So one of the things that I think we want to have here is, if I, for example, write code that tweaks a type, how can I recurse back into the engine to say, hey, I may contain a reference to a type that I don't own, so somebody else might want to take care of that. So how can I call back into the engine and say, okay, if there's somebody who registered a contract for the things that are inside of me, please take care of that, right? Those are the kind of scenarios that I think we need to kind of figure out how.
Yeah, so this actually is designed already. So the get type info actually returns the nullable resolver, the nullable JSON type info. So, and the reason for the choice for the nullable in the interface itself, the lower IJSON type info resolver, yeah. So it returns nullable, and the reason for that is specifically because of the scenario you just mentioned. So, say you created your own type, I don't know, like emo or something, right? And you wanna say it serializers to whatever basically you want, right? So you react so you type your own, you write your own emo resolver, and then you say if type equals type of emo, then I return my own JSON type info, and you do whatever you want. And in other cases, you return null. So you tell users, okay, this is the resolver for my type. And if they want to combine it, at that point they would basically use the combine APIs. And yeah, right, you're right in the sense without maybe makes sense to provide them with the APIs to combine basically.
So, and if I know, let's say, I mean, this is the problem with the converter, right? Because the converter is basically, own the JSON payload for this type and everything that's inside of it. I guess with this thing, because you only handle your type and you just give some tweaks, anything that this type recursively contains is still calling back into the, okay, is anybody handling this type situation? I don't have to do anything for that to compose, correct?
Yeah. Like for the converter, in order to combine you have to call deserialize recursively or serialize. But for the resolver, like the resolver is kind of like an absolute answer. So, okay, like here is how you resolve every single type, and what you actually want is the partial resolver or some kind of whatever you call it. But basically, yeah. So design for that is basically you return null when you don't know what to happen, and then you combine that resolver with the something which gives you an absolute answer always.
Yeah.
So yeah.
Sorry.
Yeah. Can I interrupt for a second, real fast? Sorry, Emo, can you just zoom in a tiny bit? We're getting some feedback on YouTube that the screen's a little hard to read.
That would be
sorry. Go ahead,
Jeremy. But yeah.
Or Jeremy, yeah. Sorry, I'm done interrupting. Sorry.
Yeah, I'm probably just not following. Maybe I'm a little confused, but I'm trying to figure out how the combine works recursively if I call like base get type info.
No, for type info, you don't think about recursion because the types type infos are not really recursive. Once you get type info once, it's cached and you cannot modify it anymore. So basically, that's the idea. So like, say you have type emo, and then you have property which also like on that type you have a recursive property somewhere, another emo somewhere, right? So like once the JSON type info doesn't have self-references. So if you look at the JSON property info, it doesn't have JSON type info references anywhere. Like all it has is a type, and basically, yeah, you can tell it how you get that value and how you set that value, but you don't decide how the type info because it's already decided on the resolver.
Yeah, I guess my scenario is something like, let's say, take the mutable array situation, right? So let's say I want to write a contract for a mutable array, but I don't want to write how elements in the array are being serialized, right? I just want to say I only handle the array. I don't handle the elements of the array, if that makes sense, right? So I want to handle any T basically, but I create the outer wrapper. I do the builder thingy, and then I, create the actual thing at the end. So I guess in your world that would work because all I have to do is register a resolver and say if the type is immutable array of any T, then I'm invoked, and then I take care of the builder stuff, and then for the elements, I don't have to do anything. I just return null because either somebody else handles the elements type or it doesn't, but that's not my problem.
Yeah.
So in that sense, it would be it would compose, and then it just becomes an exercise of like writing the resolver that returns null, right? And then have some chaining or something.
Correct.
This is the part I'm not following though, right? Because like when I don't recognize the type, right? So like in this example that you have in the sample usage, and maybe this isn't what you'd write. It's like if type is not like my type, right? The get to generic type info, you know, isn't immutable array. I'm supposed to call base.get type info.
You might. So no, not necessarily. So it depends if you're a library owner or if you are the user consuming. So if you're a library owner, you probably want to just care about your own thing, and you don't care how user falls back. So if you are a user, on the other hand, you do care how the fallback process is being, like how the fallback process is happening. So if you're writing your own library for serializing, say in nhibernate types, you write the nhibernate thing which returns null for whatever you don't want to handle. And then the user on their own, when they combine resolvers, they say, okay, I wanna have nhibernate takes precedence over whatever, and then if I don't know, if the nhibernate resolver doesn't know what to do with that, use the default resolver or use whatever else resolver, and then you end up chaining until you either have an answer or no. And if you don't, then that means you cannot serialize or deserialize because we don't know what the type is.
Okay, if I return null, like, and I'm not a library author and I'm an app author, would I get basically the same behavior as calling base if there were no?
No, the resolver is the absolute answer. So if you create a resolver which always returns null and you assign it to options, that you will always get a throw basically on the serialization when serialization happens. Because like that means, because in some cases you might want to suppress, like you might want to say block the serialization for specific type, because I don't know, like for maybe it's for security reason or for some other reason you decided you don't want to serialize the specific type, you can actually block the default type resolver from serializing or deserializing a specific type. So the options.typeinfo resolver is an absolute answer. If you want fallback logic, you have to fallback.
So, okay, if I'm understanding this correctly, I'm a library author. I'm not opinionated on how other types are serialized other than like my collection type. I return null for types I don't know about. Now, for users to use me, they now have to like combine it with the default type resolver, and then it works. Okay.
But like, why wouldn't you like hold the base resolver in your implementation?
What the base resolver would. So, an example for surgeon scenarios,
like as
you might not wanna ever use reflection, because reflection would basically means the app is not trimmable. And for the other scenarios, the reflection is most likely it will be the way to go. But in certain scenarios, the reflection is basically you don't ever want to use it.
I see. Sorry, and then I think Imo was saying something about like with the immutable array example. Something that like struck me as wanting to process types at a generic level, like so immutable array of T. Is that the case? As in, so you want to say like I want to customize all contracts that the contracts for all types, all immutable array of T types. And I don't know. System text JSON doesn't provide a mechanism to do that now. The closest I can think to something like that is if we have some method that says like return me the list of all type infos, and then you sort of check for yourself to see whether whether the type is immutable of T array. So I guess my question here is like, is there any desire to sort of process templates for like generic types?
No, like, I mean, you have access to type, and the moment you serialize immutable of whatever, at that point you can check if the type is of immutable of T, right? So at that point you can do your own logic for that. So
I guess it's just a note here that like there will be some like redundant logic. Like there's no like one line of code can address all generic types, but maybe that goes
I
without
mean,
saying.
if they have common interface, then yes, you could technically do it, but with one you can check if it's assignable from. But like yeah, if they don't have a common interface, then that I guess becomes slightly harder. But it's still probably one-liner to check if it's immutable. All right.
And am I missing an API to return all the types in the resolver? Like, is that desired in any way?
So say again.
So is there are there scenarios where you want to retrieve all type infos in a given resolver?
Not really. I mean,
As opposed
no.
to just like knowing the type specifically.
No, I don't know of any at least.
Well, I guess if there are no scenarios, then
I mean,
we
it's
don't have to.
like if we have a scenario like that, that could be easily added in the future. Like I don't know why now. Like basically, what if you want to type info for a specific type, you get a resolver, and you basically ask it like what the type info for the specific type is, right?
Such an API is the only way that comes to mind to address like that sort of.
The only difference is you will not get a cached version, but if you ask the type info resolver like what is the JSON type info for the type you are asking, then you will get the answer.
But say I don't know the type. I just want to check for some pattern. But I guess it's, as you say, it'd be easy to do that in the future. But if the scenario doesn't exist, then we can then.
Because what you ask for is the cached version of or what?
Yeah, the cached version.
Yeah,
say the default reflection is.
No, we don't have an API,
but
yes, but if you use the same type info resolver, you will get equivalent instance of the type info, but you will not get this exactly the same instance.
Cool.
I mean, the one thing I would say is like, it seems to me there's like two different concerns. One of them is, inspecting a type and deciding whether your logic should kick in, right? So for example, for the one that you have in your samples here is you look at the data member attributes and decide whether you should do anything, right? And then there's the other concern, which is how do you compose multiple resolvers, right? Which order should they fall back in, right? And so if I were to write a JSON type resolver for, let's say, the data contract serialization, I would not derive it from the default one, and I would not basically mix these two things together to saying, I decide whether I should handle it, and if so, call the base, because now that means if somebody wants a different prioritization, they can't use the resolver that I wrote them, right? Versus if I just have an implementation of the interface where I cleanly return null, well, then somebody else can call into me. I return null saying, hey, I'm not handling this. And they can decide who the next in the chain is, if any, if it's the default one, if it's their own, if it's something else, right? So if we basically provide our own as extending the default one, then you glue these two these two orthogonal concerns together, which now makes it difficult for people to compose them. So I would say anybody who implements one should only handle their types, return null for anything else, and then there's a different set of resolvers that all they do is aggregation. And they might be chained, they might be callback-based, whatever.
If I understand correctly, what you're suggesting is to basically remove the virtual from the default JSON type info resolver and seal it?
Yes, I would basically say, and I would go a step further and say anybody who implements one should not bake any sort of fallback in. They should just return null for things they don't handle. And then just say, if you want to compose it, you write something around it.
Makes sense. Okay, so yeah,
Does that really work? So like looking at the examples for like the system runtime serialization attribute resolver, like you have to call into base.
No, because if you return to null and then you combine that resolver with the default one, that would effectively be the same.
But it's looking at the return value of base.getJSON type info.
Currently, yes, but like what Imo is suggesting to, rather than inheriting from the default JSON type info resolver, you would implement the interface directly. And rather than doing base whatever, you would do return null basically. And then basically that would be a generic purpose resolver for this specific attribute. And then the moment you want to combine it with default resolver or some other default logic resolver, you basically make a conscious decision. Okay, I want to combine this specific attribute resolver with the default one.
Well, I think what Stefan is saying is that the problem is in order for your code to do anything, you first have to get a type info to begin with, right? So you would instead of deriving from default JSON type info resolver, what you probably should do is you should just implement the interface, and in the constructor take another instance of the interface, and then dispatch to that, right? But I think the problem here is fundamentally you need to ask somebody else first before your logic can kick in, right?
I mean, in the case of what's on the screen, I don't know what if the kind is object is doing, but basically you can just ask if the type is data contract attribute, then you know that you're matching it. And then instead of calling base get type info here, you would just call go build me a new blank one.
Yeah, I guess that's fair. Well, you didn't even have to do that, but you would just say. I guess, yeah, you would have to. Yeah, you have to build a new one, yeah.
But if you build a new blank one, don't you have to recursively rebuild back up the properties and stuff?
Well, I mean, that's what the sample on screen of that you're writing an interpreter for data contract attribute is you're throwing away all the existing properties and you're rebuilding it from from that, and then it's just gonna presumably when you call on the returned somewhere up here there was go build me a, so you'll call create JSON type info, and then on that you'll call create property info, and then when that wants to go find the T, it's going to walk back through this whole resolver chain again, or single resolver, whatever you've got. I think.
Yeah, I guess the meta point here is this particular example. You're right. You would get away with not having to call one, but I think the example that Christoph had earlier, which is where you want to say all my types have an additional property that is set to some value, right? In which case you wouldn't throw them away, right? You would just say, give me the ones you think should be there, and I'm just adding mine on top, right? So in this case, you would have to take an JSON type resolver in your constructor in order to start off of something that somebody else controls, right? But I think the point is still you would never ever inherit from the default one. You would always say, give me one that I'm considering as my base, and that one is provided by somebody else. So it might be the default one, or it might be something else. But the point is that my logic is not tied to the way the fallback is handled, right? These are different concerns.
Is there an example of filling up a collection type?
No, because the finish was not in the original API proposal.
Because I'm just wondering, how do I get the sub-elements, right? What do I call into, and how can other resolvers register into that?
What do you mean by sub-elements?
So if I'm trying to build up in a custom array, right, or whatever, right, and I don't care how, the elements of the array are constructed, I just have my special way of initializing my array. How do I get the sub-elements using, if I want to combine my custom collection resolver with some attribute-based thing like we're looking at here?
So you want to have a different resolver for your sub-elements? Or I'm not sure if I follow.
Yeah, basically, yeah. I just so in this example we're looking at, sorry, I scrolled away, but yeah, the system runtime serialization attribute resolver, could I have objects with the data contract attribute in a JSON array? And if I wanted to deserialize that JSON array into a custom type that I want another resolver for, is that a thing I can do?
So yeah, currently the current design doesn't have the element converter or anything like that. That's something for later, basically.
We could still do it by just knowing the type and then getting the type info for that type, right?
Yeah, yes, because currently we're not quite sure yet if that should live directly on the JSON converter or JSON type info. And that's the concern, basically. So we need basically more time to figure out where that API should live.
Well, how is it different from like properties that exist on JSON type info? Like elements like key and value for dictionaries versus like properties on an object.
I mean,
As far as-
good point. Like, I guess the JSON type info is kind of like information which the converter, at least the internal converters, use to decide what should be happening during the conversion, essentially. So yeah, I guess that would make sense to make the internal, like the inner converters to live on the JSON type info, so that the outer, so that the converter could decide based on that information. So yes, but possibly that's the right API choice.
That might make sense, because like the equivalent to like element in a collection would be like a generic property, right? Where I don't know, like if I have a generic type and a property of type T, and I don't care how T is deserialized, but I care about like how once I have that object, I put it in my custom property.
Yeah, basically the only cases I know about is the converter for the key for the dictionaries and the element for the any type of enumerable, essentially. So those are the, like we call it enumerable, but it's actually, you know, like it's anything which basically has elements. So those are the two cases kind of we know about, and yeah, like they are not part of this proposal yet, but we had that in mind when we designed those APIs. So therefore, the JSON type info actually has a kind which returns either the object or enumerable or the dictionary.
Yeah, another option, I just posted this in chat. I mean, I've seen this pattern elsewhere. Like I think I've seen this in UI very often when you implement command handlers, where effectively the interface that handles the command takes effectively a handler that represents the next one. So each handler basically can call the next handler, and then based on the answer of the next handler, decide whether they're intercepted, whether they're modified, or whether they just return it as is. And so basically we could just change the method signature to also accept the type info resolver as the next one. What's nice about this pattern is that effectively now it's codified that these are separate concerns, right? And so anybody who constructs a resolver, they don't have to have a constructor argument that takes the next one. It's basically just every time you call get type info, the caller is passing that one in. So now they're completely orthogonal concerns, right? And so because it seems to me like, we look at just the sample on the screen, right? It seems there are many cases where your answer depends on the answer that somebody else gave, right?
Yeah.
So that's what I meant earlier by the composition of this fundamental recursive part of the type system, right?
Hammer that board.
Yeah, like like to me those are like two cases. Like one is I want to construct something from the scratch, or I want to modify existing thing. Those are like the basically the two orthogonal concerns. Yes.
Which is why I think like making that an actual argument to me would make sense. Because that now also means there are singletons, right? So basically, like every library could just have a singleton that represents their type resolver for all the types that they know about, and they don't really have to hold in any state, right? Because it's just, the next resolver is passed in as an argument, right?
Right, and what I like about that is it's not even next per se, it's recursive, right? Like it points back presumably to the beginning of the combined type resolver that's built up from these things. Like, which I think makes sense. Like if you're gonna have an API to combine these type resolvers, Like, I think you want to provide a way for a type resolver to be like, what is like the collective knowledge, especially if like we were returning null for particular types from particular type resolvers that library authors are writing, so that you're doing this combined thing.
If you're chaining these, is that like just potentially a lot of allocations to new like intermediate ones up?
Well, but I mean, we're talking about chains, but at least as proposed right now, it's the resolver.
So for the chains, like if you look at the IRIX combination patterns, it actually has that solution for that. So basically, he calls that, how do you call it? He calls it with callback essentially.
Yeah, with
So
callback and
with callback is
chaining.
basically solves exactly what you want. So you either have so the callback is equivalent to modifying, and the fallback is equivalent to basically creating your own thing and falling back to something else.
So which one would we tell library authors to do? Like if you're trying to, so for people who want to do like some attribute or something to customize serialization, deserialization, we'd want them to do something like that maybe with the callback.
Yeah, like if they just want to modify existing type info, then yes, they would do callback, and if they want to create it from the scratch, so in example like in the gRPC scenario, then in that case you call the fallback, so they create their own resolver.
Well, I guess it depends on how you want to skin that, right? My assumption would be that the library author would not call these at all. A library author would say, hey, for my types, I give you a type info resolver that represents, handling all my types. And then you compose that with yours in whatever order you want.
It sounded like Stefan was suggesting a library that defines a custom attribute that if you put on your types, it knows how to fix up the serialization, so that it's not defining their own types. It's a I'll use the ASP term, the middleware for the rewriting things on the fly. Is what I thought he was talking about. That's where you get the callbacky one. It's, well, somebody else knows how to build the base type, and then when I see this property that was declared as Stefan is great, then it replaces any strings with the string Stefan is great.
Well, the problem is that ultimately there's one single resolver, right? And that is owned by whoever owns the serialization, which is effectively the app, right?
Right.
So who is then on the hook to call the, with fallback or with callback methods? And I would assume that's whoever constructs the global JSON serializer settings for the app, right? And then the library would just give you, a way to construct a type info resolver for their types. And so as the app author, you have to effectively collect them all and then compose them in whatever order makes sense for your app, right? Which probably in many cases is just a chain and of some arbitrary order. And then if that doesn't work for you, you may reorder them or reprioritize them. But ideally, every library is independent, right? They should not have any sort of ordering issues, right? They should just handle their own types, and then that's it.
What's frustrating is that it seems like the way library authors should do it, which is returning null, means that their resolvers can't be used in isolation. So like if you want completely default behavior, except that you just want to use one library's custom resolver, like you then, it sounds like, have to combine it manually with the default resolver for it to work. Or it just has to give you like a pre-combined resolver. Like, does each library offer you two resolvers, like one combinable one and one default one?
My assumption when we were saying that the recommendation was to just say return null if you didn't handle it is that the system version of if null is what came back, it would just call default resolver.get type info.
I mean, I guess that's the question of like, if the root resolver returns null, what does that mean? Is that valid, or and then we just fall back? Or are we saying you really meant you don't want to serialize the type?
The root one, like if it returns null, that means we don't know what to do with the type, and the serializer will throw in that case.
Yeah.
At least that's how it's defined right now. And
That's
in
question. I think that's
many
kind of
cases
like
it
Stefan's
makes
point,
sense. Yeah, like so basically, like if you think about like JSON serializer context, so that's kind of a resolver. Like no matter how you think about it. So in many cases, you don't want to fall back into the reflection and not fall back into the default logic because you don't want to lose reflection. That's the one of the goals of the source gen was basically to avoid reflection. So like if we started falling back into reflection, like that basically like how do you prevent from that from happening? Like
Well,
we
instead
would
of
have to
returning
introduce
null,
a
you
lot-
throw.
Yep.
I mean, presumably if null gets returned, you're throwing anyway. So we just move the throw into the person who says stop from
Well,
this point.
No, but the problem is, I think that like Stefan's point is that as a library author, you returning null doesn't result in throwing, right? It depends on who's next in chain. If there is nobody next in
Fair
chain,
enough.
then yes, that eventually becomes a crash, right? But the idea is that if you want libraries to only handle their own types, then they have to return null. They cannot return the default one, right? Otherwise, the whole chaining, stops working, right?
I'm trying to understand when a library resolver wouldn't want to, like, unless it's meant for source gen. Like, when wouldn't you want to call the default resolver?
Because there might be another person in the line that needs to be called before you. Right. So let's say, for example, let's take immutable collections, right? I am the author of the immutable collections library. I want that my types can serialize in JSON, which today they can't. I mean, they can in Newtons of JSON because he handles them all, but like, pretend for a second that it wouldn't, right? So then you would basically say, I provide a resolver for the immutable types, but collection types fundamentally, have an inner T that somebody else has to handle, or maybe potentially wants to handle, right? So if you want to say, oh, I have an immutable array of customer, well, I know how to render the immutable array, but then the customer is somebody else's job, right? And that might not be the default one. That might be, whoever owns the customer one, right? And so the only way for my library to compose nicely is to say, yeah, I handle mine, and then somebody else is responsible for the rest, right? And the only sensible way of doing that is to say I return null if it's not the thing that I care about. And so then the library author, also then the guy that builds the app would basically say, hey, there's the immutable collection one, there's my own stuff, and then there is the default one that handles the primitives, right?
Yeah. So maybe some explicit API to fall back to default resolver. Like at the end, called by the app, the final application. That's one thing that comes to mind.
So the default one uses reflection. Is that true or is that not true?
True.
Okay, so then I guess then what Christoph said is true. You don't want to start with default all the time. You basically want the user the option to use default or throw. In which case, Stefan is correct. Like the every library author would give you a resolver that can only handle their own stuff. So if you want to use the default one, the user is on the hook to explicitly chain it with the default one, or it will not handle the primitives.
Okay.
But I mean, again, right now we're talking about chains, but and we can say it's because we want to ship one of the chain resolvers as public API in the default. But right now, what it's set up as is the resolver.
I mean, that's kind of my earlier question too, is like, if we do it like the converters, we would just say it's a list, right? And then every library just gets added to that list. And if they all handle their own types, then there really shouldn't be any ordering issues to begin with, right?
But then the list, like for modifying and for fallbacks would look like that would be two lists, right? At that point.
No, you would just process them in order. You would just start with the first one, and then if the first one doesn't handle it, you ask the next one, and the next one doesn't handle it, you ask the one after, and then if nobody handles it, then you throw.
But what happens if you need to modify something which someone else returns?
Well, that's basically, if you do what I suggest, then basically the next resolver argument in the actual interface implementation is just receiving the next entry in the list.
But you wouldn't want the next entry in the list. You would want the cooter. right? Because you
You
don't
want the-
care what the
yeah.
next entry is. You care, did the rest of the chain handle it? So you want a virtual chain resolver at that point. That's everything after you. So that
You still want
all
to
the
sort of-
cascading would work.
And
Yeah.
also notice there might be scenarios where you might want to modify what endhibernate is doing. For example, like if for endhibernate type you might want to add property, for anything else you don't. And like in that case, with the combination pattern, you can do that. If you start with the list, it's going to be harder.
Because
but
the
list
next
as the I mean, what Jeremy just said, you would handle that, right? Because your argument is basically representing the remainder of the chain entirely, right? And you can, if you want to modify that, that's fine. You just ask what the chain would think. The chain gives you back a type info, and then modify it from there, right?
Yeah, the way that you
So I
would
don't
avoid
think
it
the
without
argument-
building a new list for everything of being the cdr is that the pattern, instead of returning null, is if you have a next, return next dot thing, which is that you're responsible for chaining inside yourself. And then now we're back to you did your own chaining. What's the point?
So I don't think the resolver, right, like the next resolver should represent the remaining chain of resolvers, right? It should go back to the first element of the list. Like imagine if you have like an immutable array containing an immutable array. I mean, or that kind of thing, right? Like once you like try to call the resolver on another type, right? Like you want to start from the top again.
I guess that's true. I guess that's a fair point, yeah. Yeah, but that's kind of like why I said earlier, like we should think about how these things compose, because it seems not trivial to know what the correct answer should be. And I think, like, to me, they are not separate concerns, right? Because as I said, like if we want them to be separate concerns, these APIs need a different shape, right? And that's why I was saying we should think this through and then say, okay, maybe we don't provide, the fallback and chainer patterns. That's fine, but we should have an opinion on, or not an opinion, we should have a thorough understanding of like how these things compose, and can people actually write libraries that are independent, or can they not? Because I think if the answer is they cannot, that would be, in my opinion, a failure of the design. I think we would want a world where a library author can say, I only handle my types, and everything else is done by somebody else, but that requires a pattern where I can delegate the T for the mutable array, for example, to someone else, and even if that is another mutable array, right? That's why I was kind of saying we should design this, even if we don't ship the APIs.
And do you think with the current proposal minus the default JSON type of info resolver currently being open, it should be closed type, like, do you think you can achieve that? Like I can see, like I'm gonna.
You tell me.
Like in my opinion, yes. Like you can do it. Like the question is.
I mean, it might be worthwhile to just try, right? I mean, like try to do the immutable array example, and then try the cases where, oh, it's immutable array of customer's done by somebody else, and then if that works, we'll try immutable array of customer and see whether that actually works the way you want.
But yeah, like as I said, the JSON type infos are not recursive. Like they don't have self-references, so that doesn't. Yeah.
Even the immutable array example, struggling to understand how, like, because you can have an immutable array that is of the same type as it, like wrapping immutable array. They're two different types. So that's why I was talking about the generic. Like we don't process the types on a generic level. So I still don't understand that example.
Well, the reason why it's important is it's how it's basically like if you scroll down here in the example that we discussed earlier, right? What is it? The my type example, my customer resolver. Yeah, the actually not that one. The other one where we basically call into the thing. Yeah, here, this one here. So basically, the very first time you say base.getJSON type info, right? So if you say immutable array of customer, well, then you basically want to ask the system, okay, give me the type info for customer, right? And then customer may have registered somebody else that modifies the customer, adds some version properties and God knows what, right? And this thing only handles the immutable array case, right? But now imagine the type that is passed in is immutable array of t, right? So if I now say base.getJSON type info, that thing may not know what to do with an immutable array of customer, right? Because that's supposedly my code here that runs, right? So that's why I think it's important to think about how different types compose when all you want to do is effectively write a resolver that only handles immutable arrays with any t, including immutable array of immutable array. You know what I mean? Like that's why I mean I understand that the type info you have is one for anything, but then you need to be able to make sure that this, when you call back into the engine to ask for the resolver for the type info for somebody else, that you get called as well, right?
Often are folks like starting from scratch? Like, do you imagine that people are writing their resolvers from scratch, as opposed to, aside from source generation, as opposed to like starting from the default?
Say again. So
Right.
say you write immutable array resolver, right? And like exactly what informations do you need from the inner type info?
Well, I guess the library case. Okay, I get it. To answer my own questions.
I mean, it doesn't have properties. Like it only has number handling pretty much. So like say you wanna, I don't know, like set converter on that one. Like we currently don't have an options, but assuming this will come in the future, you set up a resolver, and then eventually like the engine will ask yourself about the inner immutable array and so forth. But like I don't kind of see like what useful informations you could get from the inner JSON type info, like for your thing, like, and even so, if let's say you find a use case, you can, I guess you could still do that by passing yourself the top resolver as well, like if you really wanted to do that. But like I kind of am failing. I guess I'm kind of failing to see like what you would need that for.
I don't see how you would pass yourself the top result.
I mean, you could pass
part of
it
the
in the
API.
yeah, like not in the composable pattern, but in the kind of standalone case, I guess.
Right,
Yeah.
but the idea is we're trying to make it easy for people to combine things. Like if I create, I mean, I guess we don't have like IEnumerable and dictionary support yet, but like say that I have like an optional T type, right? And you know, it itself could contain, because like, you know, optional, right? And eventually, like, I want to be able to both like get and set the inner type using whatever
in this case you would need
the end user set up, like the final resolver.
Yes, the type, yes, but not the type info, right?
But you would need the type info for the property info, no? No.
For the the property info doesn't have type info, JSON type info anywhere. I mean, it's kind of the same. Like, so, like how is the element different from the property info? So you have an object with the property of its own type. Like how is that different?
Yeah, I kind of assumed that a JSON property info.
No, it has a type. It doesn't have a type info. So the
I see.
so the type is being resolved by the resolver, but basically the conversion from type to type info is being done by the resolver.
Gotcha. So then you would get that part for free, I guess.
Yep. And that would be the similar for the arrays.
Yep, I believe that. So then, yeah, maybe it is a non-issue, right? It might still be useful to go through the motions and actually implementing something like an optional or, you know, the mutable array example to see whether we can actually do it. They would also like basically go back to what Levi suggested earlier, like have a way to swap out the instances if you want a builder-based approach, which immutable array would kind of force you to do. And then I think it would be pretty powerful. I think that at that point just becomes a question what to do with the default.
To be honest, like kind of currently internally, that's what's happening in my prototype. Like basically, the element type already exists. It's just internal. I guess it could be public, but I think it's called element type. And basically that's causing the resolver to pick up, okay, what is the type, and get me the type info for that specific inner element type. So basically that's what's currently is happening. So it's no different, I guess, to like what the user would do if we started extending that in the future.
Yeah.
So do we have action from any of this? Something we're changing in the API, or a comment that we should leave of what needs to be done before coming back?
So to me, the two things that stood out was one was Levi's suggestion where you want a way to support builder-based things. And then the second thing was, I think we want to make sure that when people write resolvers that we either say, yes, it's fine to extend the default one, or we're saying it's not. You should always write your own resolver in a way that you return null for things you don't want to handle. And then somebody else composes them. And that one, I'm not sure we reached consensus what should happen there, but it seems like something we should think about. Either rule it out or say, yes, we are happy with that.
I feel like if that is the pattern, to return null JSON type info for things you don't know about and construct a chain, like maybe that should be the API and options, right? Like a list or a chain of these resolvers that you can just add stuff from libraries to.
Yeah, but like that's still that the list would solve many cases, but I guess if you wanted to modify the answer for only some of the inner resolvers, then that would be much harder to do, I guess, because you would now have to know what the specific resolver is returning versus, okay, I actually want to modify every single type the nhibernate returns.
But wouldn't the nhibernate one just take a resolver as an argument and then effectively say, I always return something, either I return the one from the thing you passed me, or I return something that I adorned, right? Like it also basically my point is the nhibernate one wouldn't extend the default one either. It would take the whatever you consider the base one to be, right? Or the fallback one, right?
Correct. Yeah, but like they would actually return the resolver would be an action in that case, right? So I guess the may make sense, I guess, to add the combining APIs to the proposal in that sense. But
I'm not sure I understand what do you mean by action.
So yeah, like because there are two scenarios. Like one is you want to modify the existing JSON type info, so someone else returned the answer.
Yep.
And there is a fallback logic. So first you start with the fallback logic. Okay, I know what this type is. I want to give you the new JSON type info for that type. And then once you finish and you define, okay, this is my JSON type info, now you go with the modifying type info, I don't know what you call it, resolvers. But you start with the modifying and basically adding the properties every library wanted to.
The modifying one is the one we currently have on the screen, right? The only difference is that it's not an extending default. It's calling into some other resolver, right? So the base.getJSON type info would be some other resolver.getJSON type info, right?
Correct. So this guy would have to be public void, I don't know, like modify or something, and JSON type info basically. And that would.
What's weird about this one is it's not. Like, it is modifying, but it doesn't need to be because it's outright replacing. So this one could be whole cloth. It's when you want to add always strip off a property, or always add a property, or you want to inspect all the properties and see if they have some attribute, then do something different to that property. And that's when you need to compose at the beginning of the list so you can cascade call to the rest of it. Or depending on how it works at the end of the list, so you can get the previous handled. So the list and composition mechanics I do think are a part that's missing here, and we can certainly say it's up to somebody else to make their correct linked list, but we should, instead of taking the notion of like, oh, we could do something like this, that basically it becomes an official part of the proposal.
So do you, so the suggestion is basically, instead of having the type resolver public on the options, have two lists basically, and one of them would be for modifying and one would be for the fallback logic.
I mean,
but that's the answer. That's one possible design, right? I think to me the bigger problem really is like what Stefan said earlier, right? Like, imagine you're the app author, you're building an ASP.NET app.
Mm-hmm.
What is our recommendation? What people should write, right? And it shouldn't just be, / think about it and figure it out, right? It would be like, what do we think common patterns end up being? So, maybe what you just said is the common way. We just say there's two things, and you either add it to this list or that list, and which one you use will depend on what library you're using, and they will tell you which one to use, right? That's a reasonable way to do it. Or maybe you end up with two different interfaces, right? Where the interface is kind of self-documenting. You have one that, takes the type, take options, gives you back a JSON type info. The other one is void, takes the type info and modifies it, right? And then it's like, well, you can't mess it up because the library gives you either that type or that type, and they only go into one of those collections, right?
Correct, but like, what if you wanted to create extended and hibernate? So say someone extends over what hibernate does, and only what hibernate does.
To be clear, I'm not saying that's the right
like
answer. I'm just saying think about it and then say which one you think is the correct answer.
Yeah, so like I am kind of convinced the iJSON type info resolver and the current base design without the combination will allow you to solve every scenario, but at the same time, I am not saying it's the easiest. But like, at the same time, to me, this is not a type of API you would kind of use without knowing what you're doing, I guess.
Yeah, I think it would be fine with the absolute resolver as proposed here. Just, we need to make it easy for someone to say, I want to load in the JSON, the source generated JSON serializer context from 3 different libraries that I'm built on top of, and then also work in the pipeline whatever in Hibernate does. And so, like, we just need to make the pipelining easy, that they can build the one absolute resolver that's the pipelined resolver.
I can propose a simple solution for that. So say on the default JSON type info resolver, we've added lists for the fallback and the basically for modifying only. So in those cases, and basically those two lists, like you mentioned before, so that would cover all of the default, like the most common cases. But if you want to do something more exotic, then you still have an option to create the resolver from scratch. So the usage would be basically options.typeinforesolver equals new default JSON typeinfo resolver, and then you say provide a list in there on the console member, like maybe on something, basically on like, you would have to think up of the good name. But basically, there provide a list of the all of the callbacks for the modifying and the fallbacks, but the kind of reverse fallbacks. So basically the thing which extend on the default one.
I guess at this point, I think that the answer is, try it, write it, and then.
Okay. I also think we need to really have a very crisp opinion on is it good or bad, or it depends whether you should extend the default one. And because my concern is that people extend the default one, the library will work, but only if it's the only thing that needs a resolver. As soon as you have more than one resolver, I don't think you want libraries to ever extend the default one.
I think we've already agreed on that it should be sealed.
Okay.
Default one. I agree on that. Given with what all being said today, I agree this should be sealed. My proposal is to add two properties basically on the default JSON type info resolver to allow you to extend, do the basic extensibility. So if an Hibernate wants to add something, you would do new default JSON type info resolver, and then you pass my own custom resolvers basically in there. I would have to think of how they would be called or how the API shape should look like for them, but I don't think like putting the list directly on options would be a good design, solely because I think if someone started with the essentially like extended and Hibernate or something, something extending someone else's resolver, then that would basically fall apart if we started doing this more exotic stuff.
Right.
So I think that the typing for resolver is a must basically, but the that at least in my eyes at least, but
All right, so the notes I have, we asked about the iList for the JSON type info properties, and it's correct using the interface because it's a non-public type. You mentioned that create JSON property info to property shouldn't have been in the proposal, so I removed it. We added complete object to pair with create object for things like the immutable array scenario, and then default JSON type info resolver, maybe it should be sealed instead of recommending extending from it. And then that the thing that we're missing here is a working example and behavior pattern, etc., of how composition works across libraries, exposing their own resolvers, and how somebody's supposed to understand how to put anything together. So again, like this, the single resolver, and it's up to somebody to put a composing resolver in the way is fine, but I think if we're saying we want to build before and after chains and whatnot, that we should figure that out, try writing a sample, doing it, and then make it be part of the proposal. But I don't. It sounds like we shouldn't say approved until that's done. Like we shouldn't hand wave it because there's no point in going forward if nobody can do this.
And the combined patterns, like Eric wrote down, you don't think that's a good?
It may be fine. Just it sounds like that was we could maybe do something like this, and now it's like, well, try it, see if it works, and then if that works, then take those things instead of a suggestion to part of the proposal.
Okay, so like how do you define that works? Like what do you mean by that? So what I mean is basically like until like I don't know if every possible
right 3 libraries that use source generation to provide JSON serializer contexts and figure out how an application can talk across those JSON serializer contexts and something like in Hibernate or the data contract resolver, and understand how to pipeline those things together and register it in their serializer options.
Sure.
So things that are providing types from nothing, and then things that are modifying existing types, combine them together, build the unified resolver, and have somebody pretend to be an app developer and understand how they could have done that.
Makes sense.
Okay, so I will put that as the notes. Is the date only and time only thing short enough that we should try it now, or is that being punted?
I think we should punt it. I'm not prepared to talk about it. And I think Eric was the other one.
Okay.
Unless Christoph wants to drive it.
We only have 2 minutes anyway, right? So
well, if it was a 3 to 10 minute issue, then it is knocking it out important. But if it's more than that, then I think that's
I mean, it seems like an easy one, right? Is there anything controversial about it?
Yeah, so Naomi, are you just exposing these types as built-ins that are hanging off of an existing type?
I know there's some considerations around like TFMs, which I haven't. I didn't even know this was coming up today. So
okay, so we're just So we're not ready to talk about this one, and that was the list of 2 things that Emo had on the agenda, and we are out of time. So
Sounds good. Then next Thursday we are going to talk about system command line, and then next week both meetings will just be backlog reviews. So we will not tackle anything that's big. So if this thing wants to come back, it would have to wait at least a week, because we need to have some breathing room to look at the remaining list, because there's a lot of blocking ones now. So we can't postpone this forever. And I think then the week after, I think the Tuesday, I think, is blocked for Tanner's generic math. I think, right? Yes.
Yeah, on the 10th.
Alrighty.
all right. Well, we have exhausted today's agenda, and simultaneously we are out of time. So with that, I declare it to be lunchtime for people in the Pacific Coast, and otherwise simply adjourned for everybody else. I love this gavel. Ciao.
Yep, thank you.